Methods of proving triangles similar. We had 3.5. So let me call on 4 people here. Let's start. Drew, any method you want to throw at me. Angle, angle. Yep, need 2 pairs of angles. So angle, angle. Next one. We're flying here. We're flying. Don't have any time to stop. Finley? Side, side, side. And again, that does not mean all 3 sides are equal. They're in the same ratio. They're in the same ratio. All right, another way to prove triangles similar. 1-6, Bryson.
Side angle side.
Side angle side. Again, the sides need to be in the same ratio. Not equal. They need to be in the same ratio. And then the half method, if it is possible, I could do what? Cormac? Prove the triangles. Prove them congruent. So if triangles are congruent, then they're automatically similar. All right, not used very often, but keep that in mind, though. Keep that in mind. All right, so we're about to start proofs here, proving triangles similar. And I want to keep these up here before I start the proofs. These 2 right here, side, 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 and side angle side. We already mentioned the sides need to be what? In the same ratio. And the only way you can figure that out is if you know the side lengths, like yesterday. How many proofs this year have we done? Statements, reasons I'm talking. How many proofs have we done where I've given you the side lengths? Yeah, you're right. 0. 0. So what am I trying to tell you here? When we do these statements, reasons with similar triangles, hate to break it to you, those aren't going to be options because I'm still not going to give you the side lengths. So now I'm telling you even more now. What's probably the only way we're going to prove triangles similar when doing a statements, reasons proof now? Angle, angle. That's it. Find me 2 pairs of angles. These are not going to be options because I'm not going to give you the side lengths. So as we start these today, just keep in mind, angle, angle. Find 2 pairs of congruent angles for me. So let's start here with number 1. Prove to me these 2 triangles are similar if I give you WR parallel to VB. And it's got to be angle, angle. So that's all I don't care about sides. That's all you're searching for right now is angle, angle. Okay. Anybody see let's start. Anybody see a pair of angles that are congruent up here for whatever reason? Don't tell me why. Just tell me the angles you want to use. Tess.
WSR is congruent to VSB.
Yep. No. Watch your mouth. Don't. You're done. WSR congruent to angle VSB. I'm good right now. I'm good. Might not be good here, but I'm good. If you know, you know. Shar, why? Thank you. Vertical angles are congruent. Thank you. One A down, 1 more to go. I got the vertical angles, right? I gave you parallel lines for a reason, just not to read it and look at it. All right, to use it. There's a reason why I told you those lines are parallel. Give me another pair of angles that must be congruent up here. Woo. Tess, back to you. Let's go. I gave you those parallel lines for a reason. Come on.
WRS and
Yep.
VVS are congruent.
Yep, R and V. All right, R and V are congruent. Tess also could have given me W and B congruent for the same reason. All right, but we'll do R and V. So angle R congruent to angle V. Again, we could have also said W and B. Why are those 2 congruent? What type of angles are those 2 now? Let's go, Drew. Yep, good. So parallel lines imply alternate interior angles congruent. And angle. That's it. I know you guys think these should be like 8-9 steps based on what we've done in the past, but once you have angle, it's a wrap. So triangle WSR, have some self-respect, put the similar sign, not the congruent sign. Triangle BSV, angle. It seems easy, I get it, but guess what? Finding those angles sometimes are a little tough. Questions there? Vertical, alternate interior. All right, there's a part B to this, though. There is a part B. There's a part B. The triangles are similar, and now I'm going to tell you SB 10, WS 15, SV is 20. How about the length of RS now? This is what you guys did yesterday for me. And there really weren't any questions on the assignment, so I'm assuming people are good at matching up sides. You don't have to add this as part of the proof. It's just an algebra question. If the triangles are similar, sides are going to be in the same ratio, so I need you to match them up for me. All right, start us off. Give me a side from any of those two triangles, please. Give me a side length from any of those two triangles. Start us off, Drew. I don't care what you start with. 15, good for me. 15. You can start off however you want. Now I always match it up. 15 matches up with what side length in the other triangle? If you can't tell, use our similarity statement, right? That's Drew just gave us WS. So figure out what WS matches up with over here and give me that side length. All right, so what's 15 match up with in the other triangle? Henry? 10. Yep. 15 matches up with 10. And because Drew gave us a side length from the big one, I need another side length from the big one, X. And I think we know now that it'll match up with 20. Again, if you did a different proportion than me, great job. Just as long as you're cross multiplying what we're cross multiplying. It's a good proportion. All right, cross them up. I'll ask somebody in a second what you get for X. Cross multiply and divide. What'd you get for X here? Boom, 6. Alyssa?
30.
We got 30 for that side. Oh, good job. All right, any issues? All right, let's see one more. I don't do a lot of work with proofs here because there's only so many ways we can do angle. I left the colored pencils over there. I didn't know people walk by them or out, but you're probably going to need them for these. So if you want to go grab a handful for your group, one person, that's fine. Or if you don't need them, that's fine too. Just if they're probably needed on this one right here. And once you have them, let's highlight those two triangles I'm asking you to prove similar. BAD, DEA. Let's go. Okay, once you have them highlighted, start looking for angles because we need to prove them similar. Start looking for pairs of angles that might be congruent. I don't care about sides. Don't give me sides. I don't care about sides. I care about angle. So look at the givens because you are told this was a rectangle, so maybe you remember some properties from last unit. And you're given two segments are perpendicular, AQ and BD. So see if you can find any angles to use for angle, and I'll ask somebody here in a minute. So look at your two triangles that you highlighted. Can you see angle at all? Any angles? All right. Got any pairs of angles you want to tell me about? Anything you want to tell me about up here for these two triangles? Here we go. Jonathan, anything? Make sure you DAB, right? Because there's more. All right. So if that has a right angle, that tells me that my yellow triangle up here, AEB, it's got to have a right angle to match it. Right? So if the bigger one has a right angle, the smaller one's got to have one too to match it. So is there a right angle in the smaller one you want me to put in here? Two zip here, Brendan. BEA, good. So there are the two right angles. Now, when I write step 2, I'm not going to put both of them in the same step because they're right angles for different reasons. All right, so this is going to have 2 separate steps for each of the right angles because they're right angles for different reasons. So let's start with DAB. Angle DAB is a right angle. Why is DAB a right angle? Different than why AEB, but why is DAB a right angle? How do we know to put the symbol there? Ooh, Stephanie? Darn right it is. Rectangle implies all right angles from last unit. Good. Now you tell me why AEB. Different reason though. It's not a right angle because it's a rectangle, that's for sure. So how do we know AEB is a right angle now? Why do we put the symbol there? AEB. Why is it a right angle? Brendan, back to you.
With a perpendicular line.
Yeah, in the givens, we were told those two were perpendicular. Perpendicular lines form right angles. So I do need separate steps because they're right angles for different reasons. But at the end, you still need to tell me they're congruent to each other so I can have the first A in angle. All right angles congruent. All right, there's one A down. Where's the other A? Search for angles now. Search for angles. Search for angles. Where's that other angle? Where's that other pair of angles in those 2 triangles? And they have to be in the triangles, right? Not outside, not partial angles. Full angles in both. All right, here we go. See them where this is a tough pair to see. Tough pair. Stephanie, see them at all? Good job. Yep, we have a reflexive angle that's shared in both. Perfect. Good work. This angle right there. Okay. Reflexive angle in both. So angle ABE congruent to itself. There we go. And now we have angle. So again, the concept AA isn't tough, but finding those angles might be. All right, let's hit up some algebra now. My worst fear in this unit. Let's hit up some algebra. AE is x, AD is 1, DB is x, EC x plus 2. So there isn't any confusion, and you don't think you need, and you may think you need to use it. At the end, it tells you the lines are parallel. You don't write this down. Let me just show you why I needed to give you the lines are parallel. If those lines are parallel, good midterm review here. What type of angles were those called right there? Corresponding, right? And I also have a pair over here. So that the lines being parallel tells me the small triangle and the big one are similar now by angle. So that's me telling you the lines are parallel. That's what I'm telling you. The triangles are similar. So now as a class, we can make a proportion to solve because I can only write a proportion if the triangles are similar. All right, let's see how well we can match them up. Give me a side in any triangle, the small one or the big one. Give me a side and its length in either the smaller or the bigger triangle here. Start us off, Jared. Give me a side.
AD is 1.
Okay, so I don't want you to do this. I'm just showing you for teaching purposes. We're going to put AD here, which Jared gave us was 1. Good. Now your job, what does AD match up with in the big triangle, and how long is it? Here's where I get nervous. Full sides only. AD matches up with what side, and how long is it? So let's start here. Zoli, AD matches up with what side?
DB.
Okay. It's got to match up with a full side in the big triangle, and DB is not a full side in the big triangle. It is a partial side. AD is in the small triangle. What does it match up with in the big triangle?
AT.
A.
T.
Okay, here's AD, Zoli. Here we go. Here's AD. What does it match up with in the big triangle?
AT.
AB. Now here's going to be the challenge for you. How long is AB?
1 plus X.
There we go. 1 plus X. I'm going to write X plus 1, but we can certainly write 1 plus X. Everybody good? All right. Jared gave us a side AD. So that means I need another side from the small triangle, which will be, for me, AE. So this is going to start off with X. All right. What does AE match up with, and how long is it? What does AE match up with in the big triangle, and how long is it? Okay, Cormac, what does AE match up with?
AC.
AC. All right, take your time now.
It's X squared plus.
Oh, X squared. Where's
It's
that?
not multiplied.
No, you don't remember. You add them together.
So 2X plus 2.
Good. And I'm glad Cormac combined his like terms. Hey, I don't want to see this in your proportion. X plus 2. What are you going to do with that? I don't know either. Combine your like terms before you put it in your proportion. All right, good. Thanks for everyone's help. There's our proportion. Half the battle's over. The other half, can you solve it? All right, can you solve it? All right, let's cross them up, kids. Cross multiply. X times X plus 1. And then 1 times 2X plus 2. Here we go. Can we solve it? All right, distribute. Combine any like terms if there are any. X squared plus X. All right. You guys see you have an X squared and just a plain X in the same problem, so no square rooting. All right, it's got to be factor quadratic formula time. Everyone's favorite. We're not even going to do that yet until it's equal to what?
0.
Yeah, got to be equal to 0 before you talk factoring or quadratic formula with me. So move over the 2x and the 2. Subtract them over, because I'll always want my x squared to be positive. Let's say that gives me a negative x and a negative 2. All right, play a little game in your head now. Here's the question I have for somebody. 2 numbers that multiply to what but add to what? What are you thinking about? Numbers that multiply to what and add to what here? All right, Lily, ready? 2 numbers that multiply to? Okay, so we're thinking about numbers that multiply to negative 2 but add to what? Good. And I don't have many choices. All right, I don't have many choices that multiply to 2, guys. I don't. I just got to make sure it adds to negative 1. All right, so think about it. Think about it. Numbers that multiply to negative 2 but add to negative 1. Alyssa, got any for me?
Negative 2 and 1.
Good job. Positive 1. I like it. Now set them equal to 0 and solve for x. If you do that step, I know some of you don't do that step and I don't require it. All right, but if you take that next step, set them equal to 0 and solve, that's fine. If you don't do this step, okay with me too. So we get x equal to 2 as an answer. X equal to -1 as an answer. And then we're going to have this awkward staring contest at each other and until somebody tells me why I'm not boxing them in. This never occurred on day one when we did this on Friday. It didn't happen, so we didn't need to worry about it. Now we need to worry about it. Yeah, I have a diagram now that I need to worry about. And if I take -1 and plug it in for dB or AE, is that going to be possible to have a side length of -1? No, I can't. So if you plug your answers back into the diagram and it gives you a negative side, that is a problem and needs to be rejected. Is 2 okay? Take a look. Plug in 2 everywhere in the diagram. I don't think I'm going to get a negative side there, so I can accept 2. So that's the only answer I can accept. So you do need to check your answers if you have a diagram now. We didn't have to worry about that on Friday because we didn't have any diagrams, so we just accepted everything. But only if you have a diagram. All right, one more here. I'll set it up. You guys will solve it. And again, I tell you the lines are parallel just because it makes the triangle similar. All right, start it off with me. Pick a side from either triangle, please. Pick a side from the small or the big triangle to start out with. Your call here. Stephanie, what do you want to start out with? 6. Now, which 6 are you talking about? AD or CB? AD 6. All right, so we're talking AD is 6. All right, so Stephanie's giving us AD. All right. Going to need a stud for this next one. What does AD match up with? What does AD match up with? All right, Redemption, Zoli, here we go. What's AD match up with in the big triangle?
AB.
AB, good job. And now the finishing, how long is AB if you combine your terms here?
X plus 5.
All right, we got it now. X plus 5. All right, now next side from the small triangle will be X, which is ED. And what does that match up with in the big triangle with? What does ED match up with in the big triangle? ED and Dylan? ED and what side does ED match up with? BC. Now look, don't overthink this. There's nothing to combine here. You already know how long BC is. Just 6. Put 6. Done. All right. Some people think they got to add stuff all the time. No. Only if you're combining sides. I know the full length is 6, so put a 6. All right. On you guys now. On you guys to solve this. And then look at your answers at the end. In this one, you're going to have numbers that multiply to -36. You're going to have a lot of choices. All right, there's a lot of choices that multiply to 36, but only one choice will get you 5 when you add them together. So take your time. 4 and negative 9. But again, got to be disciplined if your problem has a diagram. If I take negative 9 and plug it in for ED, we're going to get a negative side length. So please be aware of your answers. So the only answer we could have here is 4. If you're having trouble with factoring, you got to do something about it. I'm sorry if I come off strong about this. You got to do something about it because this is not going to change. All right, I'm going to have you factor all the time. All right, it's not going to change if you're struggling with factoring. Do something about it, please.